All right. One more. Lord Jesus, help me. Lord Jesus, I want to be perfectly whole. Break down every idol, cast down every fall. Now watch me, and I shall be whiter than snow. Nobody's interested in my stuff. I don't know what to do anymore. Just gotta trust the Lord.
Hi, Mr. Ray.
Good day, Jacob. How you doing?
I'm well, and yourself?
I'm
Still at
doing well,
work?
thank you. Say that again.
I'm still at work, but this time I prepared for it.
Okay, all right, no problem. I understand. And then if you have to like run or do something.
Thank you. No, but I'll be here.
Okay, perfect. And that's math.
Hey, how you doing, Mr. Ray? It's William.
Good day, William. How you doing?
Good, and yourself?
I'm doing well, thank you.
Good, good.
All right, I'm just gonna start writing down the names of those who are here. So, Veronica, good day to you.
Hi, how are you?
I'm fine, thanks. How are you doing?
I'm fine, thanks.
That's great. And Jacob, just writing down your name. And Justine, good to have you as well. If you
Mr.
can hear me.
Ray,
Good evening.
good evening.
And how are you doing?
A lot better.
Okay, that's good. And glad you're back and everything's worked out.
Yes, she's home. Thank you.
Okay, great. All right, Susanna, welcome. All right, well, no Susanna right now. Alma, welcome to you.
Hello, Mr. Ray.
Good evening, how are you doing?
Good, and yourself?
I'm doing well.
Great to hear that.
And Daniel B, good day, Daniel. All right, Clemente, good evening.
How you doing, Mr. Ray?
I'm doing well, thank you very much. Hope you're doing well.
Yes.
All right, and William, just writing your name down, but greetings again.
Thank you.
You're welcome. And Raymond, welcome. All right, good to see you. Norma, are you there yet?
Good evening, sir.
Good evening. Oh, good evening, Latavia.
How are you?
I'm fine, thank you. How are you doing?
I'm good, thanks.
That's good. And Alita, that's a new name. Alita, how are you doing? Not sure if you can hear me. Okay, thank you, Susanna. I got that information. Today we're looking at scientific notation and a little bit of algebra.
Okay, thank you so much.
You're welcome. And the algebra is from lesson 1 on unit 3.
Got it. Okay, thank you.
Okay, you're welcome. And good day, Alita. Is that how you pronounce your
Yes.
name?
Yes, I'm here.
Okay, and this is your first time, right?
Yes,
Okay, and do you have the books, the 2 books?
yes.
All right, great. And do you have a calculator yet?
The phone?
Okay, I'll take that as a no. There's a special calculator that we have called the TI-30XS. It's the calculator that's used in the test. It's the only one they allow for, but it can take some getting used to, and so we use it a lot in class. It's a good investment to have. It costs about $15 to $20. That way you could be more confident on your exam and more accurate as well.
Okay, what kind of calculator is that?
It's called the TI-30XS. If you have your book and you turn to like the very beginning of the pages, it's in the Roman numeral section of the pages. It's XII, and kind of looks, if I could get it in my little thing, it looks like that. I can
Okay.
bring it up on another screen. I actually have it shared. Let's see if I can do that. And while I'm doing that, good evening, Salvador and Marisol.
Hi, Mr. Ray. Thank you.
Good evening, Mr. Ray.
Good evening, both of you, and you're welcome, Marisol. So this is what it looks
Thank
like. You find them in all of the books, very beginning. Roman numerals XII, as you see there, for 12. But this is the calculator. This is the only calculator that's allowed on the test. So they will not let you even take a little skimpy one. So if you're planning to use one, which I definitely recommend, it's the TI-30XS, and it can be used for parts of the science and social studies tests, but definitely for most items on the math reasoning test.
Okay.
All right, so the thing is, they do provide you with the calculator at the testing site. It does appear on the computer. And not only does it appear on the computer, but they actually, if you go take your test at Fontana Adult School, they provide you with one. So they actually won't let you take your calculator in there, but that way you're not looking at the button and trying to figure out how to do everything or getting confused with issues. And plus, since it has a lot of functions there that they totally allow you to use, it would be really great to know them and how to use them. So in your own spare time, you can always read over this, and this is for everyone. Remember, you can go to this page, read through it, learn more stuff. You might even learn some stuff I don't know, right? I just go by, most calculators are the same, so it's pretty just jack of all trades there. All right, so we're going to begin in a few moments. Most people are here. I had said to you guys that you could try some of the workbook questions. Did anyone try them and have any questions? So was there any questions regarding scientific notation? All right, so as I stated, in the student book, there's not that many questions of scientific notation. In the workbook, however, there are more, and I'm not sure if anyone tried any. I know George had some questions. Okay, George is here, so He just came in. He had some questions on Tuesday, and I'll give him that opportunity to ask them once he gets in there. George, are you present yet? Can you hear me yet? All right, George, can you hear me now?
Present. So
All right, so George, I was just asking, and welcome George to the class. I was just asking anyone, did they have questions from the homework regarding scientific notation? And I remember you had questions on Tuesday from the workbook.
Yeah, let me just go through.
Okay,
Yeah.
and anyone else, if you have any questions from the workbook, feel free to ask now. I have a feeling some people have not looked at the workbook, and so maybe they don't know they have questions, but it's very possible that you might. And so hopefully you can find more time to practice the problems in between class sessions.
Okay, my problem is when you look on the table on page, yes, on page 71.
Okay, 71, the planet masses.
Yes,
So everyone, just real fast, George is asking about a question on the workbook on page 71 and number 8 through 11. That's what's connected to the table. All right, so go ahead, George.
Okay. When I use my phone to, when we have the planet masses.
Yeah.
Yes, above the power of 10, more than 10 places, it does not give me the accurate answers.
Okay, yes. The phone calculators aren't as powerful as the TI 30 access multi-view calculators. So they might not be able to do the same computations. They don't have a high enough processor. So that's where having the other calculator is necessary.
But, my question is, if when we go during the examination period, can they give us the power base more than 10? Because the calculator being requested is this one that we're using.
Oh, you said with that calculator, it didn't work.
Yeah.
Okay, so what were you said you put it into the calculator to see the number?
I tried to multiply using the power of 10.
Okay, I see what you're saying. Yes. Okay. So yes, that has 24 zeros following. And these calculators only allow for, I think, at most 10 place values. Yeah. Right. So that's what you're saying. So yeah, it cannot fit that. So they're testing your ability to do it another way. And that's what we're going to do right now. I'm going to reshare the screen and practice that in a moment. I do have questions like that, and this is going to help you here. So you're going to do this question not by using the calculator. You're going to do it by your understanding of decimal numbers. And so let's do that here. I'm just going to reshare it. And then we'll come right back to that question that you have there. All right, so everybody sees the screen, right?
Yes.
So first of all, let's just recap, because this is where most people have the issue. When we're in the decimal numbers, remember we're dealing with negative powers. When we're dealing with the bigger numbers, we deal with the positive powers. So this is very similar to what the question George has. That table is asking you to compare the masses of the planets. Now, if you try what George tried, you're going to try to put it in the calculator. And what you'll notice is that your calculator cannot compute that. It is too many zeros following, meaning it's too large of a number. Now, that means you're going to have to do it by hand. You're going to have to figure out what is the bigger number by looking at two things. The first thing you want to look at is the number itself, the decimal number. So first, you're going to compare, sorry, not the decimal. First thing you want to compare is the base numbers, the base tens. So that's the first thing that you want to compare to see which numbers are the largest. So let's try this one here, number 18. Which number here would be the smallest? Because this one's asking from the least to the greatest. So just looking at the base tens, which one is the smaller value?
10
to the power of 3, right? That's the smaller value, because if I was to multiply it out, that would be 1,000. 10 to the power 4 would be 10,000.
Thousand.
Same with this one. And 10 to the power 5 would be 100,000. So you can see, if you have 23 zeros, that's going to take a lot of time. So what you're looking at is you look at the bases and you compare the exponents of the bases. So clearly here you can see that the smallest value here is going to be the one base 10 to the power of 3. Now there's only one base 10 to the power of 3, so you know that's the smallest number. However, when you keep comparing this, you'll notice that there are two, oops, let me go back. You notice that there are two base 10 to the powers of 4. So these two would be the next one, but we need to determine which one. And so that's where you look at the actual decimal number. So we know that these have the same place values, but they have different numbers. And so now we look at the numbers to see which number is least. So out of those two numbers, which one is the smaller number? 2.477 or 2.48?
2.47.
2.477.
All right, I heard both of you, 2.477. Remember, we learned to do that. We compare the place value, and because that 7 in the hundredths place is smaller than the 8 in the hundredths place, that means 2.477 times 10 to the power 4 is smaller than 2.48 times 10 to the power 4. And then obviously the last one is the one that's there because it's 10 to the power 5. Even though it has a smaller number there, 1.9, we know that that place value is higher because of 10 to the power 5, which means this is our order from least to greatest. Looking at first the powers of 10 and then the actual numbers. So going back to the question that George had on the workbook, and good evening, Dorcas, just getting your name down. If we go back to the question in the workbook, I don't have the workbook on the screen, so make sure you're there on page 71. It shows you the planet masses. It shows you Mercury is 3.3 times 10 to the power of 23. Venus is 4.87 times 10 to the power of 24. Earth is 5.97 times 10 to the power of 24. Mars is 6.42 times 10 to the power of 23. Jupiter is 1.899 times 10 to the power of 27, and so forth. So you see, those powers of 10 are really large. The largest one there, which one?
27.
27. So Jupiter is the planet with the largest mass, approximated mass, because of the power of 27. What is the smallest one that's there?
Mercury.
Mercury, because that power has 23,
3.
which means that it only has 23 place values, right? So now when we go to number 8, we kind of already answered it. Which planet has the greatest mass?
Juniper.
Jupiter. How about number 9? Which planet has the least mass? We kind of answered both of them. I didn't realize that's what they were at.
Mercury.
Mercury. And then about how many? Okay, number 10 and number 11, that's what we're about to do today. So now what we're going to do is, first of all, let me just go over how to do it with negative numbers. Once we do that, we're going to practice how to calculate. And that's how we're going to do number 10 and number 11. Now, sadly, there's no calculations in the student book. So we can't do any calculations. I can't share it on the screen. You're going to have to make sure you have your book in front of you. Now, sometimes they might ask you to do it the opposite way. They might ask you with decimal numbers, and they could switch the order. So no longer from least to greatest, but greatest to least. So that means you're looking for the bigger value. Now remember, with the negative powers, what do we mean? Do we mean small valued numbers or large valued numbers?
Larger. Small value number.
Right? So these are small numbers, less than 1, like 0.00, stuff like that. So which one is the greatest? So I switch the order. In the previous question, it was least to greatest. In this one, it's greatest to least. So be careful there. Which number is the greatest number out of the 4 that are here?
So that would be the 1.09 times 10 to the power of -3.
All right, so we hear that from Salvador. Do you guys agree? Does anyone agree with that answer?
Okay.
Isn't it,
Yeah.
isn't it 1.074?
Okay, so a little slight degree. I just want to make sure everyone is thinking about it. So we have two answers there.
We're
Anyone
looking for
else?
the smallest, you said.
The
Greatest.
greatest
Oh,
number.
okay, okay. No, he's right.
Okay, so I hear a affirmation there that the one that Salvador said is the correct one. Does everyone agree and see why he's saying that?
Why should it be the greatest, the 1.09?
Okay,
Because the other,
Mr. Ray, I changed my question. I think Jacob was right. 1.074 times 10 to the power of negative 3 will be the greatest one, not
all
the
right, well,
1.09.
Jacob switched back to you. So we
Yeah.
both of you guys have switched.
No, because if you saying the greatest, so the greatest will be actually the one closest to the positive one, which at that point will be the 1.074 times the power of 10 to the power of negative
Well,
3.
be careful before I say yes and no. Remember, these numbers aren't negative. The base 10 is negative, the exponent.
Right.
So these aren't negative numbers. They're numbers that are in between 0 and 1.
Right. Right.
They're not on the negative side.
Right.
So just keep that in mind. They're not negative numbers. So if you're wondering what I'm talking about, let's say we had 3 on a number line, just in case someone else is wondering. 3, 2, 1, and then we had 0, and then -1, -2. All of these numbers are somewhere in this region between 1 and 0. Really, really tiny numbers. They exist in a sense, but they're just really tiny. So they haven't crossed over 0 yet.
Right.
All of these numbers are bigger than 0.
So so the closest one to the 0 would be the, I know that's 0.7. Now I'm confused.
No, we're good, because if we look at the place value, we have 1.099 is greater than 7, although they both have the same exponent at -3. So we're looking at the greatest, which would be the greatest. So it would be the 1.09.
But the greatest would be I'm sorry, Jacob, but the greatest wouldn't be the one closest to the 0, and the 0.74 would be closest to the 0 than the 1.09, no?
But remember, the greatest would be in this direction.
Yeah.
Right. That's why I said the 0.7. I don't know why.
Okay, so now you got to ask yourself, because it's actually greater than 0, is on the left side of 0, which number would be closer to or being the greatest? So in a sense, you can kind of ignore these for a second.
Yeah.
You want to look at them and you compare them and they're similar. You look at just the number part and say what's the biggest.
You were right at the beginning, Salvador.
All right, now just to verify, yes, you were correct. The first thing you want to do is look at the base 10s. And at the very beginning, I kind of went over that. I'll write them out again. You have 10 to the power of 0 equals to 1. And then 10 to the power of -1 is not a negative number. It just means that number is less than 1 but greater than 0. It really means 1 over 10 or 0.1. Now 0.1 is larger than 0. You have to remember that.
Right.
10 to the power of -2 is smaller than 10 to the power of -1. 10 to the power of -2 is 1 over 100, which is the same as 100th, which is still bigger than 0. Right? 100th is the same as 1 cent. Having 1 cent is still larger than 0. So in case anyone else is wondering, 10 to the power of -3, remember that means 1 over 1,000 or a thousandth. A thousandth, if you could physically do it, will be a tenth of a penny. We just don't have a value that's small because of inflation. So a tenth of a penny just doesn't even make sense really, but it's still bigger than 1. And that numbers can get smaller and smaller and smaller and smaller. They could get so tiny that you're now entering into the microscopic or nano worlds. That's where you have cells and stuff that you can't see. Viruses, like the coronavirus, they're really tiny. You can't see them with our naked eye. We can feel the effect of them and they come into us, right? Virus and bacteria, and even other microscopic creatures that can enter into us. And we don't even know that they're there because they're so small. They're not at 0, but they're really, really tiny. So that means the bigger numbers are the smaller negative values. So you just got to keep that in mind. Sometimes you can think about it as debt. which one is bigger in terms of value, right? -3 is higher up on the scale than -5. Or you could think temperature. -3 degrees below is actually warmer than -5 degrees below 0. And so we know that our numbers have to be in between these two first, because the 10 to the power -3 are the larger base 10s. And then, as Jacob and George and Salvador were discussing, you now need to decide which one's bigger between 1.09 and 1.074.
And in
Remember,
that,
say that again?
and Mr. Ray, at that point, it will be the one closest to the 0, right?
Well, no, because remember, all of these numbers are greater than 0.
Right. But it'll be like closer, let's say from the right to the left to the 0, right?
Well, which one?
Like you have the +1. If you put a -1 here on this side, yeah, the -1, whatever is closer to the 0, no?
Well, okay, and this is where it's a little, that's why I said this one can be a bit confusing because we have negatives in the base 10. But
Right.
remember, negatives in the base 10 don't make these numbers negative. The negatives in the base 10 just say this number is really, really small.
Oh, okay.
Let me write them out completely. So this one here literally means 0.00109. This one here literally means 0.001074, right?
Oh, okay. Oh,
Now,
so
which one of
obviously
these
at that point that okay.
Right, so remember, the
yeah.
negatives in the base 10
Right.
simply indicate that you're dealing with numbers that are between 0 and 1.
Okay.
It doesn't mean that this part of the number is negative. So the number is not negative, it's actually positive. It's greater than 0, but it's really, really tiny. And we're just trying to see which one is actually the larger value. And so in this case, it is this number because when you look at this position, that 9 is larger than the 7, even if you look at it in regular number form. The 9 is larger than the 7. And because the 9 is larger than the 7 there, then we can safely decide that 1.09 times 10 to the -3 is the greatest number, do that again, the greatest number of those. And so obviously the second one is the one in contention there, would be 1.074 times 10 to the power -3. Now I made it easier. Well, I don't know what I just done there. Okay, I made it easier. The last two should be easy to decide. Which one is bigger out of 2.9 times 10 to the power -4 and 9.48 times 10 to the power -5?
The 2.9.
The 2.9, because the base 10 here is larger than the base 10 to the -5. Because on the scale of the base 10s, 10 to the -4 is larger than 10 to the power -5. And so because the 10 to the power -4 is larger, even though 2.9 smaller than 9.48, it's a bigger number if you used to write it out. This one would be 0.00029, and this one would be 0.0000948. And that 2 here is larger than the 0 there. And because of that, this number is the next number in that list in terms of greatest to least.
Got it.
Leave that up a little bit.
Say that again?
Leave that up a little bit. I want to write those down.
Okay, yeah, no problem. And then obviously that last one will be 9.48 times 10 to the power of -5. All right, and good evening, Dina.
Hi, Mr. Ray.
Good day, how you doing?
Good, thank you. Sorry. Hey, I was just going in here real quick. I am doing some errands right now, and I'm still not done, so
Right.
I won't be able to join today's class. Is that okay?
That's good. I'm glad you came in and said something. That's
Okay.
fine. So thank you.
Alrighty.
All right.
Okay, but I'm gonna try to catch up on during the weekend on today's lesson. So
Yeah, today's lesson, we're doing Unit 3, Lesson 4, but then we're going back to the beginning at Lesson 1 on that's not Unit 4, sorry, Unit 3. So we're doing Lesson 4 in Unit 3 and then to Lesson 1.
Okay, got it.
scientific
Alrighty.
notation, and then we go back to algebraic expressions.
Okay. All right, Mr. Ray.
Okay,
Thank you.
you're welcome. Enjoy your
Uh-huh.
evening. Be safe.
All right. Thank you. Bye.
All right, any questions regarding what we just done here?
No, it's clear now, Mr. Ray.
All right, great. All right, so now that we're done, can I erase everything and move on?
I'm good. I'm not sure about the rest of it.
All right, in 5 seconds, I will erase everything and move on. So if you're writing, 5, 4, 3, 2, 1. All right. Okay, now what we're gonna do is move on to, wait, hold on, let me see something first. I need to see if I have it on this slide or, okay, it's on this slide. No, it's not on this slide. Okay, let me switch completely and it's over here. All right, so the next part that George was asking about on that question, numbers 10 and number 11 on page 71. So if you go to your book on page 71, number 10 has said about how many times greater is the mass of Jupiter than the mass of Mars. And then number 11 says about what is the sum of the masses of the planets. So what you're going to have to do here is learn how to do computation with scientific notation. This is where it's really needed. Not just to write the numbers differently, but to now calculate with them. Now, there are generally two methods that we use to do that. You don't have to know both. I will show both, and you can decide if you want to know both ways or just one of the ways. But I will show both, as some people will prefer the other, and sometimes it's easier to switch. Just like with adding mixed numbers, you remember we learned two ways to add mixed numbers. We could change it to an improper fraction and add, or just add them as mixed numbers. Sometimes it's easier to use method 1 than versus method 2, and vice versa. But for some, it might be more challenging to learn both methods. So what you could do is, if you like that one method, take it and then maybe close your eyes with the other method. But let's go ahead. We're first going to learn how to just simply add scientific notation. Now, the first method is not a universal method. I call it method 1. Somebody else might call it method 2 or method 8.
Thank you, Mr. Ray.
You're welcome. All right, so for method 1, what we're going to do here, we're going to change the numbers back into regular number form. Now you can see with the problem that Georgia asked about, that might be a bit difficult because 24 zeros is a lot of zeros. But for method 1, we're going to change them back. So 1.3 times 10 to the power 5 and 2.4 times 10 to the power 4 will change into 130,000 and 24,000. So this is to do it without a calculator. We do with a calculator after. So 130,000 plus 24,000. All right, once you do that, you're going to add the numbers like you regularly would, right? You're going to have 130,000 plus 24,000, right? Hope you remember how to add if you're doing it by hand. That's going to give you 154,000 as that answer there.
Mr. Ray, let me ask, where do we have this 1.3?
Pardon?
I'm talking about the 1.3.
That's what was given.
What do we have then? What do we have the 1.3?
We changed it to 130,000.
Okay.
Remember 1.3 times 10 to the power 5, we just put 4 more zeros after. Remember, remove it 5 times to place value, what we were doing on Tuesday. Did you get it, George? 1.3 times 10 to the power 5 is the same as 130,000.
Okay, I'm right, okay.
And 2.4 times 10 to the power 4 is the same as 24,000. Is everybody okay with that?
Yeah,
Yes.
I'm just taking notes.
Okay.
problem.
All right, so once you get the 154,000, most times when you're doing calculations or scientific notation, they're going to want you to put it back into scientific notation. They ask you for it in regular number form, you're done here. But if not, if they say write your answer in scientific notation, then you need to convert that number back into scientific notation. So hopefully you remember how to do that. You want the decimal point to be in a place where that number is between 1 and 10. And that will be in between the 1 and the 5. So you move it over 5 times until you get 1.54 times 10 to the power of 5. And that's your answer. So that's how you do it with method 1, or the first method, method A, whatever. These aren't dogmatic names, so, you know, that's just how you do it one way. All right, the second method, I call it method 2. What you're going to do is just use your understanding of base 10. Now, this one can be a little bit tricky, but if you practice enough, it can actually be faster. It just takes a little bit more thinking behind it. The way that you do this one is that you want to convert the base 10s to be the same. This is literally what your calculator does when you put in the calculator. The calculator is programmed to do it method 2. So what we do here is just remember, if I was to change I want my base 10s to be the same. So I have 10 to the power 5 and 10 to the power 4. Remember, if I move the decimal point over to the 1, it's like adding 1 to my power. If I move it over twice, it's like adding 2. So if I want to change the 10 to the power 4 to be 10 to the power 5 to make the basis the same, right? I would need to move the decimal point to the left, because moving it to the left increases that exponent by 1. And you always want to choose the bigger base 10. It's always easier to do that. And so if you have 10 to the 6 and 10 to the 3, you want to change it to 10 to the 6. And so remember, going to the left is the same as multiplying by 10. Multiplying by 10 is the same as adding an exponent. So if I want to get that 10 to the power 4 to be a 5, well, that means I go up 1, and so therefore I have to move the decimal point over 1. And that will give me a new one of 1.3 times 10 to the power 5 plus 0.24 times 10 to the power 5. And if I do that, I simply add the 1.3 plus the 0.24. Remember to add decimals. Is 0 plus 4 is 4, 3 plus 2 is 5, the 1 plus the 0 is 1. And then I'm done. I keep the same base 10, 1.54 times 10 to the power 5. Now, at first glance, that might look harder, but it's actually faster, believe it or not. Once you understand that moving the decimal point to the left is the same as adding 1 exponent, you could do it very quickly. I mean, very quickly, because the numbers are smaller. It's easier to add 1.3 and 0.24 than it is 130,000, or 24,000. Or better yet, it's easier to add 1.23 and 0.24 than 132,000 and 24,000, if you get the picture. And so as those numbers get higher, it is easier to work with them. So if you look at the question in the book, which one is easier? Trying to write Jupiter out with 27 place values following and then trying to add them? Or keeping it in method 2 form and adding them if you have to do them by hand? And so learning method 2 can actually be much faster. All right, let's try another one, of course. We're going to do it with, I think, subtraction I have next. No, I just have some examples. All right, so let's just try to add these real fast. I'll just show you method 1 and method 2. We're not going to do all of them because we'll be here all night. Remember, for method 1, if you like method 1, you want to change the numbers into regular numbers. And so you add 2 more place values to the first one. And then for the second one, you add 1 more place value there. So you have 23,400 plus 2,340. When you add those 2 together, you get 25,740. But that number is not in scientific notation, so you want to put the number back into scientific notation by simply counting the place values to get the decimal point in a position where you would have 2.574, which is in between 1 and 10. So 1, 2, 3, 4 would mean 2.574 times 10 to the power of 4. Is that clear? Does that make sense? Is it easy, hard?
I think it's easier with method two, Mr. Ray.
Okay, that's good. I prefer method 2. I actually use method 2 more than anything else. All right, so let's look at method 2, especially for questions like what's in the book. Method 2 is easier if you can't use your calculator. All right, method 2, you have 2.34 times 10 to the power 4. Remember, you might want to write this down if you like method 2. Choose the bigger base. So you always keep the power of the bigger base. So what power do we want? 10 to the power of 4 or 10 to the power of 3?
10 to the power of 4.
Right, so that means the second one, we want to change that to 10 to the power of 4. If I add 1 to that 3, I have to move the decimal point in which direction?
To the left.
To the left. So that's going to be 0.234 times 10 to the power of 4. Once we do that, we simply add the numbers, and we keep the base 10. So 2.34 plus 0.234, well, you just add, we've done the movement. You just simply add those two together. I thought I had it there on the side, but I don't. So you add those two together, right? It's an easy addition because you're only adding the 3 and the 4 and the 2 and the 3 in the tenths and hundredths place. Excuse me. And so that's your final answer, the same as what's over there. And with this one, it's because the numbers are smaller, it normally makes it easier to calculate. All right, let's try the second one because that one looks like a doozy. Right, we have 1.34 times 10 to the power of negative 3 plus 1.12 times 10 to the power of negative 2. Remember, if you use method 1, that's in red, you're going to change the numbers back into ordinary numbers. Remember, with the negative 3, that number is getting smaller because that's what the negative base 10s represent. The negative 3 means you're heading in the opposite direction in terms of changing it from scientific notation into a whole number or ordinary number. In reality, you're counting your place values up. You're adding negative 2, negative 1, 0. So you're actually going up. So that becomes 0.00134. Right? 1.12 times 10 to the power of negative 2. Move your decimal point to the left twice. And you get 0.0112. This one might need you to add that on the side. And you can see with decimal numbers, it could get a little difficult. All right, so let's put this one on the side. Remember, to add decimal numbers, you want to make sure your place values are aligned. And if they're not aligned, you can put 0 placeholders. We learned that like the first week of school. So 0 plus 4 is 4. 2 plus 3 is 5. 1 plus 1 is 2. 1 plus 0 is 1. And then the 0 comes down. The decimal point comes down with it. And that's the regular number answer. But for this, we want to put our numbers into scientific notation. And that means the decimal point has to be where?
On the...
Between the 1 and 2?
Between the 1 and 2. And how many times would we have to count to get there?
3.
Close.
I'm sorry, 2.
2. And which direction will, what, if you go to the right, what type of power would that be?
Negative.
Negative. So we're going to have 1, 2 times. So that's 1.24 times 10 to the power of negative 2.
And on the negative ones, on the positive ones we use the largest how do you call it, exponent, and on the negative ones, obviously the largest too. But in this case, it'll be the smallest, correct? Because
well, okay, yeah, that's where you got to be careful. It's the smallest in terms of digits, yeah.
Right, but it'll be the smallest number, negative.
But it's a larger value, but it's the smallest digit.
Okay.
So yeah, you're right. So for method 2, the larger value, as Salvador pointed out, is negative 2. So that means we want to change the negative 3 up 1. And if we put it up 1, which way does the decimal point go?
closer to the 0, so we're closer to 2, right? Closer to the 0, to the left.
To the left, right. So we take the decimal point over 1, and therefore the exponent goes up 1. Now that the bases are the same, we only need to add the numbers. And so we could add 0.134 plus 1.12, right? They're the same now. So we just add those up. Remember, put a 0 placeholder. This addition is a little bit easier than the other one. 4 in the 0 is 4, 3 in the 2 is 5, 1 plus 1 is 2, 0 plus 1 is 1. Bring down your decimal point, and you get the exact same answer. All right, so if you don't have a calculator, if you're in a part, you know, hopefully you don't, but if you don't have a calculator, that's how you would do that by hand. All right, we're not going to do that third one there. I'm going to switch over to the calculator just to show you how to do this in the calculator. I might need since you guys are writing it down, you might just need to remind me of the numbers that are there once I bring up the calculator. Okay, so can I switch screens?
No, hold on.
Okay.
Yeah, ready.
Ready? Is that everybody too?
Yes.
All right. Okay, I'm just going to switch in a moment. For some reason, my browser closed out, so I got to reopen it. So just hang tight. I shall be there soon. And there we go. All right, loading up. And let me reshare. All right, here's my charger. No. Hold on, my battery's dying. So if you want to do it in your calculator and you want your answer to stay in scientific notation, who remembers what we would have to do first?
We press the second button.
Well, you said the second button?
The second second button.
I think it's the mode.
Yeah, we changed the mode.
Yeah, we just click mode. So just mode, and then what?
Second line, second option.
Second line, second option, SCI. The moment you push enter, you'll see it up top on the calculator, the very top, SCI. So you know you're in scientific notation mode, and so now you just need to come out. And as Gennaro showed, you could just push clear.
Right.
Yeah, it gave me a little shortcut. So, all right, so now that that's done, someone remind me of the numbers we were adding.
2.34.
All right, 2.34 times 10 to the power of 4.
4.
And then we were adding that to
2.34.
another 2.34?
Times
Okay.
10.
Oh, man, what did I just do? Hold on. Okay, 2.3. Let me move this around. I have my thing is right next to the buttons. Okay, there we go. Okay, another 2.34 times 10 to the power of what?
3.
3. All right, so we could put that right in the calculator and bam, we get the same answer. It works it out for us.
Wow.
And that's why you want to know how to use this calculator. It will save you so much time because the majority of the tests, you can use the calculator. There's only about 5 to 7 questions where you can't use the calculator.
Oh, wow.
Yeah, so you don't know what questions are going to be, and you don't know if you need those 5 to 7 questions, right? So because of that, you do want to know how to do everything by hand as well, just in case those 5 to 7 questions are the questions that prevent you from passing. So
I have a question regarding the test, Mr. Ray.
Okay,
So for the test, is it just going to be like math or like, is it going to be math, science, English, or how does it go?
Well, that depends on you. Well, they're not going to suggest that you take all 4. So you could take each one when you're ready. You could take the math test, then you could take the social studies test, and you could take them at basically any time, which means you might pass the math test in January and then not take the social studies test to December. If you guys remember, Daniel C, he he told me he was trying to finish everything in 3 months, and he actually did it. So he decided to take all 3 tests, all 4 tests, sorry, in 3 months. I'm just picking up someone's TV, so I'm just going to mute everyone. And just remember, when you're ready to ask a question, just unmute yourself. I know that the debate's tempting, so I don't want to tempt me, so I'm just muting. All right, so that's how you could do it on your calculator. Makes it very simple. Subtraction follows the same rules. I don't know if anyone wants to see a subtraction one.
Mr. Ray, just help me with the phone, with the calculator.
Okay.
If I use for the scientific, when I go through the mode, yeah.
You said how?
How to use the calculator?
So you click the mode button just by itself. Just hit mode.
Yeah. Then,
once you hit mode, you should see this option that's on the screen.
Good. Yes, I've seen it.
All right. So then you scroll down. You can scroll down to norm, and then you want the SCI to be highlighted. The way that it's highlighted, when you know it's highlighted, it's black with white font. And by font, I mean the script, the writing is in white.
Yeah.
You see the other writing is in black, so it means that SCI has been highlighted. You highlighting it by pushing enter. Once you push enter and highlight that and select it, you can tell by the calculator. The calculator tells you that it's in SCI mode, which means scientific notation mode.
Okay, at the top.
Right, at the top.
Okay.
All right, and so once you've done that, you can come back out, you can clear, and that brings you back out. And now you just type in what you see. I might forget it exactly, but 2.54, I think it was, times 10. I like to use the times 10 to the power of n button, which is right here. This is highlighted. And then just put the power. Make sure you use your arrows. And then whatever operation they're asking you. Plus, multiplication, whatever. So you hit plus 2.54. I think they were the same thing. I could be a little bit off, but you get the picture. Push the 3 and then just hit enter. The calculator does everything else. So it'll save you a lot of time and it will be accurate. As long as you type it in correctly, you will get the correct answer.
Okay, thank you, sir.
You're welcome. So subtraction works the same way. If you do it by hand, you have method 1 or method 2 and you just do subtraction the same way. I'm not sure if anyone needs to see that or you understand, just apply the same rules.
Mr. Ray?
Yes.
It's over here. I have to log off now, so I'll see you guys next week.
All right. Be safe, and remember, we're gonna try to touch on algebra today. So
I know. Can you forward me the recording if possible?
Oh yes. Send me a reminder on Remind.
Okay, I will. Thank you. Have a good evening, guys. Okay. Bye bye.
Mr. Ray.
Yes.
So I was doing the calculation on the actually on the A one, the 2.34 times 10 to the power 4 plus 2.34 times to the power 10, and so I was doing the 2.34 and then I was hitting the times, and I don't have to do that. I just have to go to the power 10 up here, on the calculator.
Yeah, you could just hit this button right there, times 10. Okay. Yeah, and it puts the exponent there for you as well.
Yeah, I put the exponent, and then I put the plus, and then same thing, 2.34.
Yeah. And if it's a negative, we had a negative. What was the negative one that we had? I forget that one. Of course.
It was 1.34 times 10 to negative 3.
Okay, so yeah, you put 1.34 times 10. Make sure you use the negative button at the bottom.
Okay.
And then make sure you come out, and then it was a plus, right?
Yes.
Plus.
It was 1.12 to the power negative 2.
Right, and then you just type that in, and there you go.
Okay.
So you basically got 3 ways you can approach it. More than likely, but I don't want to say that it will happen, but more than likely, if you do get scientific notation, you might be able to use the calculator. Most times it's with fractions, but I was told by someone they had a scientific notation question they had to do without a calculator before. So like you really don't know exactly what they're going to ask to do without the calculator. And so as long as you know how to do it, it doesn't matter. And that's why once you learn it, you want to keep on practicing how to do all these different things. And so you want to constantly review as well. All right, so let me just go over how to do I'll show one subtraction, just the example, just so that you can see it works the same. It's subtraction. If you do method 1, once again, change the numbers back into ordinary numbers. If you like method 1, subtract the two numbers. You would get, in this case, 2.6 million, 2 million, sorry, 2.06 million, 2,060,000. Then you have to convert that number back into scientific notation. All right, method 2, you can just simply choose the biggest base 10. What's the biggest base 10 there? 10 to the power of
-2 on the -1, right?
Sorry, say that again.
So when we're doing the negative ones, the smallest number is actually the one we want to use. So in this case, it will be -2.
Oh, what do I have up? I must be sharing something else then.
I'm looking at the calculator, Mr. Ray.
I'm looking at the calculator.
Oh, you guys are still at the calculator. My bad. I'm showing you guys stuff, and you're probably like, what is he talking about? All right, so I thought I had it on share screen. So here's subtraction. Sorry about that. Thank you for letting me know. All right, so if we do subtraction, everyone sees the PowerPoint now, right?
Yes.
Okay, perfect. If we do subtraction, what we notice is that we do the same method. We can change the numbers back into ordinary number form. Then we subtract the numbers just like we would if we was doing the addition. Once we get our answer, we change that number back into scientific notation. So that's method 1. Remember, method 2 is to basically choose the biggest base 10. And out of this one, what is the biggest base 10 number?
6.
6. So that means we want to change that 10 to the power 5 to 10 to the power 6.
So
and if we do that, what do we do with the decimal point?
Move it over to the left.
Move it to the left. Remember, because when we multiply by 10, it's the same as adding one exponent. It goes to the left. So that means when I change that 5 to a 6, I move it to the left. It changes the exponent up 1, and that's my new line. Now I can just subtract the number parts because we're going to end in base 10s to the power 6. So we subtract 2.3, subtract 0.24. That could be done in your head, 2.06. And then we just connect that with the base 10. And we get the same answer. All right, you could try that in your calculator. Just go ahead and do that with the subtraction sign. See if you get the same answer, 2.0 times 10 to the power 6.
So 2.3 times.
Mr. Ray,
Yes.
I did it on the calculator. It didn't come out like that. I did 2.3 times 10 to the power 6 minus 2.4 times 10 to the power 5.
And it didn't come out that way, you said?
It came out, yeah, to minus 100,000.
Oh, that's because your calculator is in the wrong mode, but it should have came up to 100,000 though.
Okay, so I have to change the mode?
Yeah, you need to change it back to scientific notation.
Okay.
SCI.
Okay, so I just hit clear?
Or let me
hit enter?
switch from this screen. So hopefully everybody has that. I'm just going to switch over. So remember, you click mode and make sure SCI is highlighted.
Yeah, I got that, and then it's highlighted, so I hit enter.
Well, now that it's highlighted, yes, you push enter to make sure that it stays highlighted, and then you can click clear to come back out.
Okay, now I got it. So let me see. Let me go back.
think this is what it was. Somebody could correct me if that's not right.
That is correct, Mr. Ray.
All right. Okay, yeah, it should work. So just try that again.
I think sometimes, Mr. Ray, when we do times the power of 10, we hit the times button, which I was doing that at the beginning, and you don't have to. You could go straight to the 10.
Yeah, you could just do that times 10 to the power of n button, and that would do it.
So, Mr. Ray, correct me if I'm wrong, Daniel, he did all 4 tests in 3 months?
That's what he, from my understanding, yes. Yeah,
I mean, I could see 1, but 4? How do you do that?
He did all 4. He said he wanted to get it done, and he was set on getting that done.
I can't keep up with 1. I don't know how you do 4.
Well, it seemed like Daniel already had some understanding of some of the topics, so that really
Yeah,
helped.
he's a pretty sharp man.
Yeah, so don't feel too bad. He already had some prior knowledge. So, you know, he had prior knowledge. All right, so you said, I'm trying to read your message, Alma. You're saying that you had, okay, it sounds like you're doing this, Alma, if you could look at what I'm doing. It sounds like you're doing this, 2.3, and then you're hitting the time sign, and then you're hitting the times 10 to the power of n.
Yes.
You have to make a decision which one you want to do.
Oh, okay, so I just choose 1?
Yeah, just choose one. So if you like times to the power of n, that's all you have to do, 2.3. And
Oh,
then
okay.
notice that times 10 to the n has the multiplication sign attached to it.
Oh, okay. I'm sorry. I was like, what is wrong? I'm doing it wrong. Okay.
All right.
Thank you.
You're welcome.
But Mr. Ray, my own calculator is different. I don't know. I've been doing the
They're all the same. Just tell me what you're doing.
You got it? Yeah, when I multiply 2.3 times 10 to the power of 6, is it give me the same? I don't know. I'll put in the scientific mode.
You said it gives you something else?
Yeah, if I multiply 2.3 times 10 in the power of 6, it still gives me the same problem. I don't know why.
So what do you mean the same problem? What's the problem that
The
arises?
answer comes the same, 2.3 times 10 to the 6th power.
Well, it sounds like you haven't added yet. You got to add on the other item.
What?
Because you remember, I don't have it in front of me, so I think it was 2.3. Where's this thing?
2.3 times 10 into the power of 6.
Right, but then it's added on to something else, so that's just the first number. So you have 2.3 times 10 to the power of 6 plus, or subtract, whatever it was. Subtract something else. You have to put that number in there as well.
Okay.
So I can't remember what it is, but it's something else.
2.4.
Right, 2.4 times 10 to the power of 5, I think I put.
Times 10 to the power of 5. I have 0.10 into the power of 0. Why that doesn't give me
0.10 to the power of 0.
Yeah.
It sounds like you typed in, you said 0.10. Sounds like you put in 10 to the power of 6 there at your second number.
It is that is the subtraction comes 2.4 times 10 into the power of 5.
Well, what did you put for the first number then?
Okay, let me go back initially.
Whatever you done, you have your bases the same. And so what's happening is just subtracting these two numbers. That's the only way you get that answer, is if you made the basis the same. So you either had 10 to the power of 6 for both of them or 10 to the power of 5 for both of them. That's how you get
10 to the power of 6.
Yeah, so you want to make the first one 10 to the power of 6, the second one 10 to the power of 5. So type what you see. Yes.
I think I did this earlier. I forgot to bring down, after I did the 10 to the power of 6, I forgot to push the arrow down, and it did give me a weird number like that. So I think he's probably not bringing down the arrow.
That's possible, but based off of his answer, he had told me 0.1 times 10 to the power of 0. And that's the answer that you would get if you subtract 2.3 and 2.4, you get 0.1. And in order to get a power of 0, you would have the same basis. So that's what it sounds like he done. But yeah, you do have to make sure you bring your arrow down, or else you're typing everything on the top.
So the answer is 2.06 to the power of 10.6.
Yeah.
Yes, that's the correct answer.
Okay, I got it right. Thank you.
You're welcome. All right, George, were you able to get it?
Mr. Ray, I'm still on that calculation. I don't know what I really done with my own calculator. I don't know.
Can you put it up on
2.3.
the screen? I just want to see what you have on there.
Yeah, 2.3.
There, can you put it up on the camera? See if you can watch what you're doing. That way you can see exactly where you're putting it.
Yeah, I did the same. 2.3 times 10 into the power of 6.
And then
So
what?
2.3 times 10 into the power of 6.
Then make sure you use your arrows, as was stated earlier. You want to bring those your arrow down, or else you'll be subtracting up in the exponent.
Okay, I didn't use the arrow down. That is a problem.
Okay, there you go. I forget who said it, but yeah, you're correct. He had the arrow up on this one. So yeah, make sure that you bring down the arrow. That's a very common mistake. For instance, it might be 2.4 times 10 to the power, and you keep on typing up here, and you're like minus 2.5, etc. So you got to look at the screen and notice, wait a minute, that's too high there. And if you do that, you're going to get something really, really crazy. And I think Justine had said that to me. But yeah, if you do that, if you got 0 times 10 to the power of 0, it's very possible. But it sounded like you said you got 0.1. So you got to make sure you bring the arrow down. All right, so with that, let's just try to do it with your calculators. Those who are finished, page 71, number 10, go ahead and try that. Now, we haven't done multiplication yet. I'll just tell you this is multiplication or division. But go ahead and use your calculator to find that out.
More. 42.
Mr. Ray, on page 71 on the student book?
Yeah, student book, page 71, number 10. All right, George, were you able to get it?
No, sir, I will still do it because it seems as if the arrow, I didn't put the arrow, but let us go with the new this thing. I will do it later on.
Yeah, you want to practice that. It could really make life a bit easier once you master it.
Okay.
All right, so like I said with that one on number 10, we haven't got to the multiplication and
Mr. Ray,
division.
what problem are we working on?
Page 71, number 10.
Is this student book or workbook?
The workbook.
Okay, workbook. Thank you.
Yes, you're welcome.
Yeah. Let's see.
Okay, thank you, Adriana, if you're still there.
Isn't 14 and 3. Oh, the same. into lesson 7. Lesson 1, lesson 2.
All right, the rules for multiplication are very similar. I'm gonna go ahead and just quickly, briefly go over how to do it. Same thing, method 1, method 2. So if you figured out how to do number 10 on there, well done. But let me just show you what it will look like. So let's say now you're multiplying. So the sign in the middle changes from plus or minus to multiplication. You can do the same thing in method 1. You can change your numbers into regular numbers and then multiply them. Now you can see doing method 1 in this method can be very challenging because multiplying big numbers like this can take a long time. But I chose easy numbers here just so that it wasn't overwhelming. So 20,000 times 300,000 is going to be, what's that? 6 billion. And then you got to change that number back into scientific notation. 6 times 10 to the power of 9. So very, very similar. The only thing that changes is that you're multiplying now. Method 2, same thing. But this time, this is where the rules are slightly different. When you're multiplying, and hopefully you hear me, when you're multiplying for scientific notation in method 2, the rule is slightly different. You do not need to make the basis the same. Is everybody clear on that?
Yes.
All you need to do is what we've already done in the past. You're going to multiply the number parts together, and then you're going to multiply the powers of 10 together. So you're going to have 2 times 3, and then 10 times 10 to the power of 4 times 10 to the power of 5. The 2 times 3 gives you 6. And then remember, when you multiply bases that are the same, you add the exponents. So 4 plus 5 gives you 9. And you get the same answer, 6 times 10 to the power of 9. So that's really, 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 really important to remember, especially because if you have to do scientific notation, multiplication or division by hand, it is generally easier to do method 2. Because trying to multiply large numbers like you see Mercury and Venus can get really out of hand and messy. But in method 2, all you have to do is remember it's a slight change in the rules. Multiply the numbers together, then the basis. But the reality is the majority of the test, you should be able to use your calculator. And that's why you really want to master the calculator. Because if you could just put that in your calculator and move on to the next question, why not do that? All right, so here we have the answer there. Any questions about multiplication?
No.
Oh, and so in addition and subtraction, you make the
basis the same.
This is the same. In multiplication, you just add them up.
Well, yeah, you multiply the bases and add them. You don't have to make them the same. There's no need to do that. I mean, you could, but you don't need to.
Mr. Ray.
Yes.
So for this kind of problems, can we use the calculator also for it?
Yep, you can. You could type it in just like you see it. You could do that right now, and you see you get 6 times 10 to the power of 9. So actually, go ahead and try that. See if you guys can get that same answer that's on the screen, 6 times 10 to the power of 9, simply by typing it in the same way, but making sure you put multiplication there.
So, okay.
Yes, I got the same one, Mr. Ray.
All right, that's great. All right, so make sure if you have to do that by hand, I don't think you have to, but just in case you do, remember you are multiplying the numbers together and then the base 10s.
So do we have to change it to scientific mode?
Your calculator should be set to scientific notation. Whenever your answer should be in scientific notation, you want to make sure your calculator is set in scientific notation. All right, can I move on from this screen? I didn't hear any no's. What I want to show you next is what happens sometimes. Sometimes you can have, okay, here we go. When you're doing method 2, sometimes your number can end up bigger. So you just want to be careful. So if you look here on B, method 2, sometimes when you multiply the numbers together, 5.36 times 4.25, and then the bases, with the numbers, sometimes it can go very large or larger than 10. So you notice there it ends up being 22.78. And then when you add the bases, -2 plus -3, it's going to give you -5. However, you remember and to be scientific notation, that number has to be in between 1 and 10. So you want to move that decimal point over to the which direction?
To the left.
To the left. But when we move decimal points to the left, what happens to the base?
It drops.
In this case, yeah, it's dropping because we're adding 1, so it's going to go to -4. And so when you move it to that 1, remember that's like the same as saying 10 to the power of 1. And when you combine those two together, that's why it goes up to 10 to the -4. So just keep that in mind. If you ever have to do it by hand, you get on there and the like no calculator part, and then you multiply it, and that number is greater than 10. You want to just remember going to the left increases the exponent. So you might want to copy that one down for sure, just to have it as a reference.
And if it wasn't positive, would it be, the number would be higher at that point, right?
Right. If it was +5, it would have went up to 10 to the power of 6. All right. I think the last one does the same thing, if I remember correctly. Let me see. Yeah. So here, very similar. It was a negative again, though, but 3.642 times 7.1 gives you a large value, larger than 10. And when you do the 10 to the power of 4 times 10 to the power of -1, gives you 10 to the power of 3. So this is an example here, Salvador.
Okay.
Once again, 25.85 blah, blah, blah is larger than 10. So you need to move the decimal point in which direction?
To the left.
Left.
To the left. And when you go to the left, what happens to that exponent?
It'll be a 4 because we're moving it to the left.
Right. It turns up to a 4 because you moved it to the left, right? Moving it to the left is adding another 1, and that 1 plus the 3 is what's going to give you 10 to the power of 4. So that's by hand. By hand, all you have to remember is that, and in reality is you can do method 2 of the addition and subtraction for multiplication, but I mean, if you could save a step, you can. If you forgot it and you did it like method 2 in addition and subtraction, you still get the same answer. So, you know, either way, you should be fine doing this by hand. All right, the last thing I want to go over, are you serious? I don't have it on there, is division. The last thing I wanted to go was division, but it looks like I somehow didn't have it on there. So just bear with me. I think I had 2 of them. Let me see if this one is on here. All right, so with division, I'm not sure if you see it anymore. Let me see. All right, here it's. And just to show you division, and you can check all of these with your calculator. Once again, method 1 is the same. You could change the numbers into regular numbers, divide, blah, blah, blah. Method 2, very similar. Just like how you multiply numbers and multiply the base 10s, here you divide the number parts and then divide the powers of 10. So you simply say 12 divided by 4, and then 10 to the power of 9 divided by 10 to the power of 7. 12 divided by 4 is 3. And what do you do when you subtract? I mean, sorry, I just said it. What do you do when you, what do you do when you divide bases that are the same with the exponents?
Subtract.
Subtract. Yeah, I said the answer. But yeah, 10 to the power of 2, and you see you can get the same answer, and you can do it relatively quickly. Now, that's what you're doing for number 10 if you haven't figured it out already. So number 10 says about
yeah, that's what I was going to ask. This would be the method that it requires a division.
Yeah,
find
it's
the
a
difference,
required
right?
division between the two
Yeah,
numbers
okay.
there. Now you can see if you try to do method 1, if you try to do method 1 with number 10, you're going to be writing
So
from a
many
little bit of
zeros.
time. Yeah. And you might not even be able to fit it in the calculator. And that's what I think George was alluding to. So this is where you want to know how to do method 2 if you don't know how to use your calculator. Because those who don't know how to use the calculator like I'm teaching you are going to try to do it in the calculator the way I've done on the screen. They'll divide 12 divided by 4, they get an answer. Then they're doing the calculator 10 to the power of 9 divided by 10 to the power of 7 in their calculator, and then they'll modify it. But you know how to use your calculator now. You can type it in exactly as you see it, and your calculator will give you the correct answer.
Let me mute this.
All right, so let's go ahead and try that if you haven't done so already.
On the calculator, Mr. Ray?
Pardon?
On the calculator, you want us to try that on the calculator?
Going to try number 10 if you haven't got the answer. I saw some answers pop in. I was just trying to check in the chat again. I saw one answer, so somebody gave the answer of C. All right, so number 10, if we do that on the calculator, I think I'm sharing my calculator, yeah. Number 10 says, about how many times greater is the mass of Jupiter than the mass of Mars? Now be careful. If I said that I weigh 80 pounds and a child, well, I don't weigh 80 pounds. If I say I weigh 180 pounds and a child weighs 20 pounds, how much greater is my weight than the child's weight? Now, you don't want to subtract there, because in this, it says how many times greater, means that you're dealing with multiplication or division, because it says the word times. If it was just greater, you could subtract. But because it says how many times greater, it means there's a multiple happening. So you would have to divide 180 divided by 20, and that will give you your answer. But in this case, we have Jupiter being 1.8. If I could get my pen, sorry. We have Jupiter being 1.899 times 10 to the power of 27. That's a lot of zeros. Which will be divided by Mars, and Mars is 6.42 times 10 to the power of 23. Now, if the question says to do this without a calculator, remember you divide these two numbers first, and then you divide these ones here. Remember, you might need to do long division if they ask you to do it without a calculator. You have to do 1.89 divided by 6.42 using long division till you get to your number, and then subtract your base 10s. That's if it's without a calculator. If it's with a calculator, then you can just type that right into the calculator. And if you do that, you're going to say 1.899 times 10 to the power of 27. Make sure you use your arrow to come down, or else you could get a crazy answer. Divided by Mars. Mars was 6.42 times 10 to the power of 23. And then just hit enter. Now notice. Let's see.
Okay, so the options as answers is rounded, huh?
Yeah, it's rounded, but I'm wondering why mine came out with a 4.9. I must have typed something in wrong. But it's not letting me see. So I typed in the wrong exponent here. So 27 divided by 10 to the power of 3.
I got the same thing.
For some reason. This is weird. It's not subtracting the answer, which it should.
I got the same thing too, Mr.
Yeah,
I got the same thing too.
You know what? It's order of operations. Put it in parentheses. The calculator's reading to divide the 6.42, and then once it gets an answer, is timesing it by 10 to the power of 3. So let's do that over. Put it into parentheses. So you're going to put in 1.899. You could put just one of them in parentheses, the last one, but I'm going to just do everything since I already started. Just put 27, bring your arrow out, put the parentheses, divide it by, and then open parentheses. This way your calculator divides it correctly. What your calculator was reading, if you can see my screen, what the calculator was doing, it was taking, come on, Pan. It was taking this number and dividing it by 6.42. Once it got an answer, it times it by 10 to the power of 23. So you got to tell the calculator, no, I don't want you to do that. Tell the calculator, what I want you to do is take this number and divide it by that number. So you're going to put parentheses in between them. So you're going to have there 6.42 times 10 to the power of 23. And I put 10.
That's the same answer again, Mr. Ray.
You shouldn't.
I get the same answer too.
What? That's not right. No, see, you don't get the same answer. You guys must have put the number else.
Yes. No, we also got the 10 to the power of 3.
You got 10 to the power of 3, right?
Yeah.
Last time you would have got 10 to the power of 49 if you didn't do the parentheses.
Right.
You use the parentheses, you get 10 to the power of 3, which is a completely different number. I mean, completely different. Now, the digits are the same, yes, because remember, you're dividing the numbers. What your calculator did the first time was divide the numbers, which is correct, 2.9, blah, blah, blah. But if you don't have the parentheses, your calculator gets the base 10 wrong.
Mr. Ray.
So you want to make sure you get the base 10 right. And so you put the parentheses in. Yes, George?
Okay. Let me ask, we divide this 1.899 over 6.2.
Well,
Then
that's if you do it step by step, that you can do it that way.
Yeah, let us try this method. Let us divide this one 1.899 over 6.42.
You're gonna get the same answer that's right here, 2.9579433925.
Okay. Then what? Then about the notation.
And then with the, well, you're gonna let's do it the long way. So that's the short way. First of all, if you look at that question, you see you're gonna have to round. So if you round that number, I'm gonna get to your one soon, George. If you round that number, what would it round to?
So that again.
Asking a general question. What? Okay, Veronica answered it. What would that round to? If you round the big number there, 2.95, blah, 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 you're going to round to 3. So that answer is the same as 3 times 10 to the power of 3. And which choice selection is that?
Yep.
B, right. Veronica sent it in the chat. That's correct. B would be your answer. Now, let's say you don't like typing it all in there. You can do it step by step, and you can still use the calculator to do that. So what you can do is do it step by step, like I said, number with number. So you could take Jupiter 1.899 and divide that with the 6.42 and find out what that answer is. And then you could take, like I said before, you could take the 10 to the power of 27, which belongs to Jupiter. And you could divide 10 to the power of 27 with the 10 to the power of, what was it, Mars? 23. Mars, 23. All right, so if you do that part, you could do that in the calculator. You could just say 1.899 divided by 6.42 and just hit enter. Now you'll notice here that the calculator is putting it into scientific notation form because we have it in SCI. If you didn't want it in scientific notation form, let's just say you were dividing it just to divide it, and you did that same thing, and you divided it, you're going to get here 0.295794393. And then with the base 10s, remember when you're dividing base 10s that are the same, you subtract. So 27 subtract 23
is 4.
It's going to give you 4. So that's times 10 to the power of 4. However, this is not in scientific notation form. So in order to do that, you're going to have to move the decimal point to the right. Now remember, when you move it to the left, you add 1. So when you move it to the right, what do you do with the base 10?
You take one.
You take away 1, so it becomes 2.95794393 times 10 to the power of 3, because you're going to be taking 1 away. And that's the same answer you would get if you just typed it all in with parentheses. So you guys remember that, to type it in with parentheses or you will run into trouble. And so once you get here, you notice that in your answer selection, you're going to have to round it because none of the answers look like that. And they're rounded to the whole number in the number part. And if you look to the right, that's a 9. So that 2 changes to a 3 times 10 to the power of 3. And 3 times 10 to the power of 3 will be letter B.
Okay, similar.
In the GED test, we are allowed to use the calculator in these operations.
Yeah, you're full. You can't stop you.
Okay.
As long as you have that calculator in your hand, whatever you know how to do, you can utilize.
Okay.
So the more you know how to do with it, the more you can get done. And that's why you want to practice it. If you read the beginning of the book, it actually tells you how to do all these different things as well. It might have some other stuff. I've never really read through it, but it has a lot of instruction how to use the fractions. I think it shows you how to do, it shows you how to do the exponents and scientific notation. If you look on 13 of the Roman numerals, it shows you how to do fractions, square roots, squares, negative signs, etc. Mixed numbers.
Yeah, okay, good.
Yeah, so it's all there that you can do. It doesn't teach you everything that I've been doing, but I will show you even more stuff as we go on. You see there data and PRB, that's probability. It can do probability and statistics. That's the STAT and the data. The data, you can actually do tables. So when you get to graphing, you can put your information in and it can do the tables for you.
Cool.
It's a very powerful calculator and can really help with your accuracy if you know how to use it. All right, any other questions there? All right, so if you look at number 11 is pretty long. So number 11 is where you really will want to know how to use a calculator. Number 11 wants you to add up all of the masses of the planets.
All of the masses.
In scientific notation form. So if you used to do that by hand, that would take you some time doing it by hand. You would either have to change all the numbers into ordinary numbers, add all the numbers up, and then change the numbers back into scientific notation. Or you would have to try to get all the bases the same, converting all the decimals and then adding them up, and then converting where need to. Both methods will take some time. Or you could just type it right in your calculator. Which one do you guys want to do for that one?
Type in the calculator.
Type that thing in the calculator. And that's why I'm teaching you how to do it for a problem like that. So let's just do that one real quick just to show how convenient your calculator is. So you want to make sure you type it correctly. Remember, with addition, you don't need the parentheses. You can put them in there if you want. But with multiplication, you definitely want the addition of parentheses. And we'll learn that again when we do the order of operations. If you know the order of operations, you have to have the parentheses because it does whichever one comes first. But with addition, it's just going to follow what you type in. So you want to type in there 3.3 times 10 to the power of 23. Make sure you use your arrow, plus. You can see this even takes a while, but this is much shorter than doing it by hand. To the power of 24 plus 5.97 times 10 to the power of n to the power of 24. You can see if you mix something up, it can really mess you up, so you got to really pay attention. 6.42 times 10 to the power of 3, and see if you could get it before I do. Don't go so fast that you mess up. 1.899, 1.899 times 10 to the power of 27. And this will actually help you with computing this.
Mr. Ray,
yes.
I believe our calculator will not carry because we have the capacity is not all that. Because my own ends with 9. I think with 9 digits.
Well, that's the beauty of scientific notation. It allows you to calculate without having all those digits.
I've been doing it like that. I've not been having the rightful answer. I don't know why.
So you already done it and it didn't work?
It didn't work.
All right, so what you could do is do part of it and then do the other part, like stop halfway, like don't finish it. So I see it's blinking funny there. So we stopped at 26. Which one is that? 5.68. So Saturn looks like that's the furthest you could go when you hit Saturn. So you can add up to Saturn, and then you can add on Uranus. So now you can say, let me add that to Uranus, which is 8.68 times 10 to the power of 25. Use your arrow. So did everybody see what I done? When it starts to blink in the finish line thing, it means that you're finished. You can't go any further. So I stopped at Saturn. I hit enter to get the total up onto Saturn. And then immediately if you push plus, it adds on to the last thing, which is the sum of the planets to Saturn. Then I have there 8.68 times 10 to the power 25 for Uranus. And then the last one, Neptune, 1.02 times 10 to the power of, what's that, 26? And as long as I haven't messed up a number in that, I should get the right answer. And yeah, if you look here, 2.6, they're going to round that up to 2.7. So it's going to be 2.7 times 10 to the power of 27. Which choice selection is that?
A.
That's going to be choice selection A. That's correct. All right, so you see how that actually saved a lot of time there? Does everybody see that?
Yeah.
Yeah, so that saves us a lot of time.
Mr. Ray, yeah. I was, because I one thing that I forgot was my calculator, but I was looking at the possible answers, and based on the rules and the process on which we do it, I was using a process of elimination. So I was guessing because our biggest exponent up here is 27, so it was going to be 1 with a power of 10. Times 10 to the power of 27. So that would eliminate and bring it just down to 2.
Okay,
so
yeah,
discard
you could do that. That's great.
I was just trying to play around with it in my head and then just use common sense and based on what I already know. So it dropped it down to only 2 options, and now just getting the right one, 2.0.
Right, it gave you a 50-50 choice selection there.
Yeah,
and you're on the right track because 10 to the power of 27 is so large that the only way that you could go higher was if 10 to the power of 26 was like 9 point something, where the 9 point something and the 1.8 will make it go over to 10 to the power of 28. But it's so large, and 10 to the power of 26 is not as high that, yeah, more than likely it's going to stay in the 10 to the power of 27 area. And because it's 2 of them, and you might have heard me say that before, most of the GD questions, you can boil it down to either the correct answer or 2 or 3 answers.
Yeah,
most times
that's what I was trying to do, because I didn't have my, while I was waiting for you to put all that, and I was like, okay, well, it's going to be times 10 to the power of 27, but which of both of those is
Which
it?
one, yeah.
I was just
if
waiting
it
for
was
the
just 10 to the power of 27, yeah, you could have guessed that one and got it right.
Okay.
Yeah, and
I
sometimes
just
that happens. Sometimes they might have, like, they could have gave you 2.7 times 10 to the power of 27, and then the rest were like 28 or 29s.
Right, yeah.
Look at it and say, oh, yeah, obviously it's going to be A.
Yeah.
And you remember, we actually did that in ratios one time, where I was like, you could actually cancel it right down to the correct answer.
Yep.
Yeah, sometimes it works every time. Sometimes it gets you down to 2. And then every so often, it might only get you down to 3. But most times, you could get down to 1 or 2.
Yeah.
Mr.
Right. Great observation, Jacob. Yes, George?
I was thinking that we multiplied 3.3 times 10 into the power of 23. Then 4 0.87 into the power of, into 10 into the power of 24.
Well, let me show you why you don't want to do that. If you want to, it sounds like you want to get the actual answer. If you do 3.3 times 10 to the power of 23, look what happens. The calculator, even though I don't have it set in scientific notation, automatically puts it right back in scientific notation because the calculator can't handle that many place values.
God, that was what I've been doing all throughout my life. I only have problems.
Yeah, the reason why is there's 23 place values there. Just to show you, this is how many place values you can put in this calculator. You can put more in your computer calculator if you open it up on your computer, but the amount of values you could put in there, you could just do it by typing. If I type in here 1, you can count how many those are by just putting, let me see. If you put it to scientific notation and hit enter, you can see how many place values your calculator. So your calculator can do 74 by typing, but when it calculates, the process of calculation creates more data to be used, and it lowers that number from 74 drastically down. So when you're actually doing the multiplication, like what you're doing here, times 10 to the power of n, your calculator can only hold up to a certain amount of value, so it's just not going to bring it up. Does that make sense?
Let us just do it once again, sir, please.
There's a long, you mean to add all of those up again? That's going to take some time again, but just basically you just want to practice typing that in. Just trying to make sure you type it in correctly, and then each time just putting it with a plus sign. So I'll scroll up to where I did it, right? This is where I did it. You just type in 3.3 times 10 to the power of 23 plus 4.87 times 10 to the power of 24 plus. And like I said to everybody, you're watching your cursor. Once that cursor changes from black to a finish line, if you ever watched a race, NASCAR or the F1 cars or any motocross race, they have the checkered flag. That means it's done. Your calculator will start blinking a checkered flag, meaning I cannot do any more. And so what you saw I did is I stopped at Saturn. That's when it started to blink. I pushed enter and it gave me the sum from Mercury to Saturn, which was this one right here that's highlighted. Once I found the sum from Mercury to Saturn, immediately I added on, just push plus, and it's going to add on to the sum. I put an 8.68 times 10 to the power of 25 plus 1.02 times 10 to the power of 6. Hit enter, and it gives me 2.667, blah, blah, blah. I look at my answer. I see that if I round this to 2.7, the answer would be A. All right, so that's scientific notation. There's other questions in there, and you know, you still want to try to practice some. And if you have questions on Tuesday, you can bring them after practicing some more. But if there's no other questions now, I'm going to introduce algebra to you tonight in the last few minutes that we have.
Okay.
So is there any more questions about scientific notation?
Let's go to algebra, Mr. Ray.
All right. I didn't hear any rebuttals.
Not right now, thank you.
Say that again.
Not right now.
No, not right now as in no questions, or not right now I don't want to see any algebra?
Not right now, I don't have any questions.
Okay, I was going to say, all right, we have somebody who doesn't want to see algebra. All right, so let's go ahead and look at some algebra stuff here. It's the same unit, but it's in lesson 1. I feel they had it rearranged because to do some algebra stuff, you actually need to know how to do exponents. And so they kind of have it mixed up there. So we're going back to lesson 1 on unit 1.
Workbook?
No, the student book first. In the student book, it's page 50.
Got it.
All right, so just going to introduce it, and we'll pick up the rest next week.
You said 50?
Yeah.
I think it's page 50. 50 in the student book.
Student book?
Yeah, in the student book.
Oh, I'm on the workbook. 50.
All right, so what am I sharing right now? Do you guys see something on the screen?
Calculator.
Okay, thank you, because I have so much stuff open, I was like, I didn't even know where I am. Okay, there we go. So now you should see the screen, and we're going to lesson 1 of unit 3. Lesson 1, unit 3 is the algebraic expressions and variables. Now, what you see here is all on my PowerPoint. So you can follow on page 50, but I have the exact same thing on the PowerPoint because it's just easier to see. So I'm switching from here, but you can follow along if you want to, as I stated in the book, page 50. Now, I did add some more stuff that I thought the book should have had in. So it's just a little bit different. And you should see my PowerPoint screen now, right?
Yep.
All right, great. Okay, so algebraic expressions and variables. Now, it's really imperative that everything that we have been learning, you still review. Like the other class is just a little bit ahead of you guys. And we are now using fractions again in algebra. As I said to you guys before, you're going to see proportions pop up in algebra. You're going to see decimals and negative integers pop up in algebra. You're going to see everything that we have learned in unit 1, even what we just learned with exponents, pop up in algebra. And like I said, if you've mastered it, it's going to help you tremendously in algebra, because algebra builds off of number sense. Number sense is basically arithmetic, what we've been doing. All right, so algebra generally it was actually like founded in Saudi Arabia, but it's basically a technique of using unknowns to assist you in solving questions. You could solve it another way, but algebra makes it a little bit more efficient and more procedural based. And so it becomes really easy to solve complex things. Just like how proportions was more procedural, proportions is literally an algebra-based type of solving, whereas ratios, we were writing them and the numbers are all kind of scattered, but in proportions it was very neat and very predictable. That's a form of algebra. Algebra makes it very easy to solve complex equations. And so we're going to learn how to do it, because that's what we do in the modern civilization. We use algebra to do these heavy calculations that basically run our world. Run your computer, runs the cell phone networks, run your pay and your salary and your taxes. All of that is basically the backbone behind all of it is algebra. So let's learn the basics of algebra. The first thing that we want to do is know what a variable is. A variable is a letter that's used to represent an unknown number or value. That's probably a better way to say that. An unknown value. Now, the more popular letters that we use are X, Y, Z, A, B, C, and R, S, T. Those are the real popular letters. Now, in reality, you could use any of the 26 letters. If you like to use the initial of your name, you could do that. If you wanted to, you could draw a cat to represent the unknown, or even a question mark. It is just a representation to say we don't know what this is right now. Once we move from the variable, we get what's called a term. And you want to get used to the terminology, right? A term is the product of 2 or more numbers. Does everyone remember what the word product means?
Product.
Multiply.
Multiply, right. So a term is basically when you multiply 2 or more numbers or variables together. So here's an example. I have the number 5 multiplied by the variable x. Now, in algebra, we no longer use the cross multiplication symbol because that looks like an x, no matter how you write it. Some people try to write their x's, in a different way, but generally in algebra, you will not see the cross multiplication sign anymore. You will either see 5 times x, like that, with a dot. We call that dot product. Or you might see it as 5 times x using parentheses, or you just might see it written right next to each other, 5x. All of these mean multiplication, and the word product. That means to multiply. But you will not see cross products anymore. Cross product meaning the x looking multiplication sign. Okay, so we're going to put that to the side now. Every so often you might see it just to help you understand, but generally you won't see it at all. Okay, so here, this means 5 times the unknown variable x. So we just say 5x. This is 3 times y times z. And this one here is negative 10 times r times s times t. Right, if I was to write this one out using the cross product, it would be negative 10 times r times s times t. But in algebra, that looks like I'm writing 10x rx sxt. So instead of writing that, I could write it like this, but that just looks redundant, even with the dot product. So the easiest way to write that is just to put them next to each other. So never forget that. A term is the product of 2 or more numbers or variables, and what is happening there, the product means multiplication. Okay, once we build up our terms, if we now add or subtract, and I should put in here adding and subtracting. If I add or subtract terms, variables, or numbers, then what we get is what we call an expression. Not an equation. We'll get to an equation soon. An equation is different than an expression. An expression just simply means you have a term or more and you're adding and subtracting them together. So here's an example. We have variable w plus 3. That's a term, an expression, sorry. X subtract 2, an expression, because you're subtracting the variable x and the number 2. This is also called an expression because you have 3y subtract z. And then last of all, this is a combination. You could have as many being added or subtracted as can be. You have 4a plus 3b subtract c. That makes it an expression because you are adding and subtracting terms together. All right, does that first page make some sense there? Did it help out a bit?
Yeah.
Okay. Now you want to make sure you review this so that you understand it. Is there any questions regarding what you just heard?
Can we repeat the class with you again for the next semester?
Now, like I told my other class, you want to think positively. Algebra, we use it sometimes and we don't even realize that we're doing it. Just like in every other math, all the math basically is literally the scripting of reality, meaning it's observation. We notice something and we're like, okay, how can I write that down on paper? How can I write it down so I could store knowledge for later on or a later generation so that we can continually pass on knowledge? And so we're learning more and more about the world around us. And just to show you how easy it is.
Okay, Mr. Let me ask.
Let me finish real quick. Let's say I say to you, I want you to count all the cars in a parking lot. Let's say we are at a car dealership and we work there, and I ask you to count all the cars in a car dealership, and then I say add 3 more cars to the count because we're getting 3 cars tomorrow. And I'm like, okay. Before I do that, do I know how many cars are in the parking lot?
Yeah.
No.
Do I know that if I'm being asked to count it?
No.
Yes.
No, I don't know.
Oh.
So what I can do is I don't know, so I just put an X there. But then I was told to do what? Add how many to it?
3.
3. So I say X plus 3. And that's literally what we're doing in algebra. It's saying I don't know how many cars I have, but just so I don't forget, it's going to be whatever the amount of cars is plus 3. And if I really wanted to help my mind out so I don't get confused, I could say C plus 3 for cars. The amount of cars that I count plus 3. Does that make sense?
Yes.
Yeah.
If I said to, as well, I own 2 car dealerships and I just so happen to have the same amount of cars, but I don't remember how many. I lost the manifesto. Can you go out there and count the amount of cars and just remember it's going to be double the amount because we have the same amount. I own a Toyota car dealership and a Honda. It's the exact same amount of cars. We don't know where the manifesto is. Need you to go there and count it. Well, if there are C amount of cars and there's the exact same amount in the other lot, that's 2 times the amount. Which means if I count 50 cars in one lot, how much do I have altogether?
100.
100.
100, right? 2 times 50, or 2 times the amount of cars. And then if I still have that add 3, because we've got 3 more coming, I have an expression, 2c plus 3. Now this is where it gets really big. If I work for Tesla or GM or Honda, and where they create cars for the whole world, and you're trying to keep what we call synergy. That is not the word I'm looking for, but most of these big car dealerships and these big franchises, they keep everything the same. And so if this was to represent everything that I had, I can put this now into software, and once I get the count, I put it in there, and it's all distributed to everyone. And so if you're at a managerial level, you are doing stuff like this. You are taking things and you're creating expressions. When they create the taxes, the tax refunds, that's what the people in the tax refunds are doing. They have to calculate this for millions of people. And sometimes you don't know what people are going to get, but you have a formula or an expression that will work once you find out what the stuff is. And when you get George's information, you just put George's information in, the answer pops up in the computer. Or Veronica's or Clemente or whoever, or myself, our information comes in. If the software automatically calculates it for us, just like the calculator, and bam, we have our answer. And so what it does, it actually makes life really easy. And so the more algebra we know, the more we can make life easier, the more we can program computers. And now, if you guys may know, we have self-driving cars. The technology is there, and it's a lot of computation involved. I used to, before I did math, I was doing computer programming, and you have to program everything to do. You're programming the car, the computers, and you're gonna put in expressions and formulas that once the person types something in, up comes the answer, right? So that's what the algebra part is. We're gonna learn more about that, but make sure you ponder over the definitions. If you have any questions with the scientific notation, that's the homework. It's simply to review the rest of the questions that I assigned before on page 70 to 73. Any of the other scientific notation questions. You could skip anything with algebra. So if you see like X, anything like solving for X, don't worry about that. Only the scientific notation and exponent stuff.
That's on the workbook, right, Mr. A?
The workbook, yes. So just finish any of the other questions.
So that was page 71 and what?
That was page 70 to 73. And if I remember correctly, it's like number 1, number 2, number 3. We just did 8 through 11, so you don't have to worry about that one anymore. I've already assigned 4 through 6, but if you haven't done it, do that as well. Number 18 to 24. So 18 to 24, and then number 30. So you can also throw in 26 in there. So it's basically the same numbers.
Is it on what? Is it a student book or workbook?
Student book. I mean, sorry. The workbook.
Workbook.
Thank you.
Yeah, my bad. Page 70 to page 73 in the workbook.
18 to 24 and 30.
Say that again.
18 to 24 and 30, right, Mr. Is that what you said?
It's basically, if you haven't done it, it's basically numbers 1 through 11. We did some of it in class. So 1 through 11, 18 through 26, and number 30.
Mr. Ray.
Yes.
I'm gonna leave, okay?
All right. Yes, you guys are dismissed. Just
thank you for your time.
Enjoy your weekend. Have a great day.
Have a blessed weekend.
Good night.
Nice weekend, and thank you.
You're welcome.
Good night, everybody.
Good night.
Night.
Good night, Mr. Ray. Thank you.
You're welcome.
Have a good weekend.
Yes, thank you. You guys enjoy your weekends as well.
Thank you.
You're welcome. Enjoy your evenings. Be safe. If you're traveling, drive safe.
Mr. Ray.
Yes.
So I have a question. This is about when can we try our GED test?
Oh, if you're ready to try the practice test, I can get that for you. I could just ask the school for a GED ready voucher, and you could take the practice test. The practice test is very, very similar to the real test. It's basically almost the same. And what it does, it provides feedback and shows you where you're strong, where you're weak, and what areas to work on before you take the actual test. It costs $6. Right now it's on sale for $3, but the school sponsors it for free under the request of a teacher or student.
Yeah, Mr. Ray, I think that after this algebra and the equation, I can even go in for, because certainly this most of those questions will likely come in.
Yeah,
So
so
I need to
I
cover this
normally
class.
suggest that after algebra, you should try the practice test, and then if you do well, go ahead and try the real test. If you don't do well after the practice test, my suggestion is to wait till we finish geometry, and then hopefully you'll be ready for it altogether.
As soon as we finish this algebra, I will go in for.
Yeah, I mean, technically, if you know how to use the calculator, you should be able to get through most of the tests, even if you're not that good in the algebra and geometry.
I'm gonna hold off into the algebra in like George said. So.
Okay, my suggestion, and right now my plan was to get you guys the vouchers in November, because by November we should be finished algebra and started geometry, and I was going to get you guys the vouchers, and my goal is that everyone takes the test before December is up.
Yeah, exactly. Before November ending, we are through with the voucher for the first test.
Use the voucher for the practice test, and
The
then
practice
take the
test.
test before this year is out.
Yeah, no, I will do so.
All right, great. That's what I want to hear.
Sounds like a plan.
Yeah, and remind me to say that again. If I've said it to different classes, so sometimes I think I've said it to you guys, but clearly I didn't say it to your group. So if you guys can remind me, if you remember on Tuesday, that I remind everyone, the goal is to take the practice test in November, the real test anytime after that.
Yeah, at least November 20th.
That's the goal. November 20-something, we should be finished algebra and started geometry. So yeah.
Yeah. Okay.
All right. So you guys, enjoy your evenings. Be safe. Have a great weekend.
Thank you, Mr. Ray.
You're welcome. All right, Salvador as well. Ray and Daniel.
Mr. Ray, I had a quick question.
Sure.
Now let's say we take the test and we go through the whole process of all that stuff. How far along are you going to go as far as the book goes? Are you going to finish the entire book? And let's say we don't feel comfortable yet, or we're not confident in ourselves as far as taking the GED test. Can we retake your test or your class?
You can retake it. We've had people who've retaken it multiple times. I heard they send an email out though, given a restriction on how many times you could take it though. I'm not sure if you got one.
Okay.
But I had some students saying that the most you could do was 3. I'm not sure. They just told me that this morning. So I was going to ask, did an email go out saying that? Because we do have students who have taken classes multiple times. I've had students who've taken like one teacher 3 times, another teacher twice. But you don't want to get like that, because sometimes they get so scared they never take the test. And then after a while, you start to be negative, and then you never do well.
Yeah, because I've noticed, because of my work schedule and me just trying to, listen in while I'm driving home and stuff like that, I'm like, dang, I feel like I'm like falling behind a little bit.
Right.
I'm trying to play catch up while I'm at home and practice, but nevertheless, I feel.
Well, Daniel, I'll say this much: I haven't heard many questions from you. So come next week, I'm expecting to see some questions then.
Okay. Yeah, it's because a lot of times too, I'm coming home from work and I'm like trying to pay attention. I'm driving, you know what I mean?
Right.
I'm
So
still trying
what
to
you
commit,
can do, because it might be hard for you to get the questions, send me the questions on Remind or email.
Okay.
And then I can address them in class so you can see them, or, and I'm about to put the videos up again on YouTube and stuff.
Oh, cool. Yeah. When are you going to do that?
The recorded, I just need to start uploading them. I was going to edit the beginning and the ending, because the ending sometimes have conversations like this, and I don't want it all over YouTube where people can hear me talking to you.
Oh, got you. Yeah.
So I have to edit the beginning and the ending, because the ending normally have people asking questions, and in the beginning, people are asking questions.
Yeah, if you do that, that would probably really help me out, because then I could just go back, review it, and look at, certain steps that I might have missed or I might have had.
Yeah, so I started to do that with my other class, and I have them labeled by what we covered in class that day. So I'm going to start doing that you know, it's going to take a while to get up to here. Well, not
Right.
necessarily. I might be able to get it done faster than, especially over the weekend, if I just start uploading them.
Gotcha.
Yeah.
Okay. And then I gotta, I don't know if you can help me with this, but I'm gonna have to maybe call the Fontana Unified School District or Unified Adult School or whatever. But I got a call from them the other day. It was from, I guess she's like the principal or the doctor or something like that. I don't remember. I guess. I don't really remember. I was in the middle of work. Yeah, I was in the middle of work when she called me, and she was saying that I had to every 2 months have to retake a assessment test.
CASAS
And
test.
okay, and she told me that I scored a 240 on it, but I need a 246 in order not to have to retake it at all anymore. So I was
Right.
like, there's like a 6 points. Does that really matter? I mean,
Yeah, it's a government thing, so it's
okay.
like, yeah, it does. I know it might be frustrating, but it's part of the district and California state requirements. So adult school students have to take what's called the CASAS test. And so you are supposed to score that amount if you're registered in the program. And it also helps too, it's kind of a twofold thing. When the schools actually do what is required, the district sends more money to the school. So that's one reason
Gotcha.
why Fontana Adult School is free and they give you books and all that stuff, because they normally keep on, we ask the students, if you do what the state requires, we get more funding, we get more programs, more free stuff. Like for instance, Redlands Adult School, you have to pay a pretty high price to actually enroll. And then you have to pay for everything because, they don't really get their students to do what's required of the state.
I got you. Okay, I'll definitely reach back at her tomorrow and hopefully set something up for Monday or Tuesday then.
Yeah, and it does seem a kind of overbearing, but that's just how California is very bureaucratic.
Yeah.
So, yeah.
Yeah, sounds good. Okay, yeah, definitely then. All right,
All
Mr.
right.
Ray, I won't take too much more of your night, and I appreciate it.
Yeah, no problem. And I'll try to get this stuff on as soon as possible for you guys.
All righty, that sounds
All
good.
right. Enjoy your evening.
All
Be
right,
safe.
You too. Thank you.
Okay. All right, you're welcome. Bye. All right, Ray, are you still there? All right, I'm logging off.